In this video, I'm going to show you how to solve the ALEKS problem calculating the heat of reaction from molar reaction enthalpy and the mass of a reactant. In this problem, you're going to be given a balanced chemical equation and its value of delta H. And then you'll be asked some questions about the equation. The first question that it's asking us is if the reaction is exothermic or endothermic. And that information we get from the sign of delta H or the sign of Q. When delta H is negative, the reaction is exothermic. When delta H is positive, the reaction is endothermic. Since this has a negative delta H, this is an exothermic reaction. Now the question is asking us if we react 89.9 grams of NO2, our reactant, will any heat be released or absorbed? Well, since we've stated that this is an exothermic reaction, whenever this reaction takes place, heat is always going to be released in this case because it's exothermic. So we can say that yes, heat is going to be released, and we'll make a note of that down here. Heat will be released when delta H is negative. Heat will be absorbed when delta H is positive. The last question is asking us to calculate how much heat is going to be released or absorbed from the reaction of 89.9 grams of NO2. So to solve this problem, this part of the problem, we're going to be using delta H like a conversion factor between the energy, kilojoules, and the quantity, moles. Even though it's not specifically written with the kilojoule per mole unit, we can make the assumption that this delta H value is negative 55.3 kilojoules per mole. The way that we interpret this negative 55.3 kilojoules per mole in the context of this equation right here, we say that there are negative 55.3 kilojoules of heat exchanged for every 2 moles of our reactant, NO2. So in this, I'm using the stoichiometric coefficients from the balanced equation just to give us a relationship right here. Even though all we need to know is the relationship between the heat and NO2, because that's what the problem is asking us, we could also write a similar equation if the problem was asking us about N2O4. And it would look like this, N2O4. So again, just using the stoichiometric coefficient from the balanced equation, there are negative 55.3 kilojoules of heat associated with the formation of every 1 mole of our product. So again, since the problem is asking us about NO2, this is the conversion factor that we want to use for this particular problem. We're going to treat this like a stoichiometry problem. So we'll start by writing the 89.9 grams of NO2. That's the information that has been provided to us. We will convert that into moles of NO2 using the molecular weight of NO2, which is 46 grams per mole. And then we're going to use our kilojoules per mole conversion factor, 2 moles of NO2, negative 55.3 kilojoules. Now the way this ALEKS problem is worded, it's just asking us to provide the absolute value of the energy, so we don't need to worry about the negative sign. This is going to be releasing 54.0 kilojoules of heat for the 89.9 grams of NO2. So the answer here is going to be 54.0, again, because it just wants it in an absolute value.